let's start electrostatic energy and energy density. So electrostatic energy in electrostatic field. First thing is this is a derivation for obtaining the energy equation. Half epsilon E square എന്ന് പറയുന്ന എനർജി ഇക്വേഷൻ ഡ്യൂ ടു ഇലക്ട്രോസ്റ്റാറ്റിക് ഫീൽഡാണ് ഐഡൻറ്റിഫൈ ചെയ്യാൻ പോകുന്നത്. സോ അപ്പോൾ ഈ കേസിൽ ഒരു ബിഗ് സർഫേസ്, ഫസ്റ്റ് തിങ് ഇസ് വി ഹാവ് ടു അസ്യൂം എ ബിഗ് വോളിയം, റൈറ്റ്? സോ ദിസ് ഇസ് എ ബിഗ് വോളിയം. ദിസ് ഇസ് വെരി മച്ച് ബിഗ് എനഫ്. അതിൽ നമ്മൾ വി ഹാവ് അസ്യൂം 2-3 പോയിന്റ്സ്, 0.1 and 0.2 and 0.3. randomly take 3 points. Then ഇൻഫിനിറ്റിയിൽ നിന്ന് ഓരോ ചാർജ് വീതം Q1 എന്ന് പറയുന്ന ചാർജ് ഈ വോളിയത്തിൽ ഇൻസേർട്ട് ചെയ്യുക, Q2 ഇൻസേർട്ട് ചെയ്യുക, ദെൻ Q3 ഇൻസേർട്ട് ചെയ്യുക, റൈറ്റ്? സോ we'll see again the work done in moving each of these charges from infinity to that point, right? So this is the volume, big volume we are assuming. This is infinity, assume that this is infinity, and I'm considering 3 points, right? So if I'm moving a charge from infinity to this point and the charge be Q1, since there is no other charges in the volume, already charge illathathonde work done namukku assume cheyam it to be equivalent to 0. Then from the infinity itself we are moving, this is 0.1 I'm assuming. From the infinity itself I am moving another charge, say Q2, to say 0.2. Now there is a potential difference due to this first point charge. So between these two, നമ്മുടെ equation, work done in the equation ആണ് Q2 into V21, right? V21 is a potential at second point, P2, due to first charge Q1. Now let's take a third charge which is again moving into the third position, and let the charge be Q3. Now what will happen? You have V31 as well as V32, because അവിടെയുള്ള ചാർജ് എക്സ്പീരിയൻസ് ചെയ്യുന്നത് 2 എന്ന് പറയുന്ന പൊസിഷനിലെ ചാർജ് പൊട്ടൻഷ്യൽ ഡിഫറൻസ് കൊണ്ടും 1 എന്ന പക്ഷം. സോ ഇറ്റ് ഇസ് 3-2 and 3-1. സോ Q3 V31 plus Q3 V32. Now our order of inserting charges is like 1, 2 and 3, right? Ini total work done in positioning the 3 charges. We have placed the 3 charges and the order is 1, 2, 3. So adding all this thing, WE will be equal to W1 plus W2 plus W3. W1 is 0, this is W2 and this is W3. Now I'm taking the same volume, right? And I'm taking the charge from infinity, and this is my position 1, this is my position 2 and position 3. So in this procedure I'm repeating the process in such a way that I am moving firstly this charge Q3 on to the third position. The position right now I'm assuming, first position assuming is 3. So what is the work done? It will become 0, right? And secondly I'm moving on to second position and I'm calling it as charge to be Q2. Now what will be Q2 power work done? It will be Q2 into V23. Why? Because 3 is already there now. So Q2 into V23. Now I am going to insert the third charge or the another charge, say Q1, and I am placing it onto first position. ഇനി ഇപ്പോഴത്തെ ഒരു സിറ്റുവേഷനിൽ ഇവിടെയും ചാർജ് ഉണ്ട്. സോ V21 and V13 are there. So Q1 into V21 plus V13 is available. So these are the two equations. Now the order is 3-2-1. Earlier the order was 1-2-3, right? Now so these two equations are 1 and 2. So I'm going to add these two equations above these two equations, this one as well as this one I'm adding. So I'll get 2 WE over there, and we have to add all these things, right? So I'll get Q1, take it outside, so V12 plus V13 plus Q2, taking it outside, V21 plus V23 plus Q3 I'm taking outside, V31 plus V32. So what is 2 WE? This can be written as 1 2 plus 1 3 can be written as V1. This can be written as V1. This can be 2,1 and 2,3 can be written as V2. Then 3,1 and 3,2 can be written as V3. So is equal to 1 by 2 into WE will be 1 by 2 into this much terms. So this can be written as what? 1 by 2 into sigma of QK into Vk, as k is tending from 1 to n. If you are inserting n number of charge, this is the total work done, right? The total work done. This is an important equation of n point charge. Now let's see more precise value. So what we have obtained earlier is what? WE is equal to total work done is equal to 1 by 2 into sigma of QK into Vk. But what does charge Q can be written as, or sorry, rho V can be written as, or charge density can be written as Q by volume, or you can write Q is equal to rho V into V taken over an integral, volume integral of rho V dV we can write. Q can be written like this, right? So നമ്മുടെ ഇവിടുത്തെ സിഗ്മ ഓഫ് ക്യൂ എന്ന് പറഞ്ഞാൽ റീപ്ലേസ് ചെയ്തിട്ട് ഇൻറ്റഗ്രൽ ഓഫ് വി ഇൻറ്റു റോ വി ഡി വി എന്ന് എഴുതാം, റൈറ്റ്? സോ integral of, if we are having a volume charge 1 by 2, equation becomes 1 by 2. Sigma of q ne replace it. Our equation was 1 by 2 sigma q into vk. അതിലെ ഈ സിഗ്മ ക്യൂവിനെ നമ്മൾ റീപ്ലേസ് ചെയ്താണ് എന്തുകൊണ്ടിരുന്നത്? റോ വി വോളിയം ഇൻറ്റഗ്രൽ ഓഫ് റോ വി ഇൻറ്റു ഡി വി, റൈറ്റ്, ഇൻറ്റു വി കെ dv you can write. So volume charge ആണ് ഈ കണ്ടീഷൻ. നമ്മളിവിടെ അസ്യൂം ചെയ്തിരിക്കുന്ന വോളിയം ചാർജ് ആണ്. ഇനി സർഫസ് ചാർജ് ആണെങ്കിൽ സർഫസ് ഇൻറ്റഗ്രൽ റോ എസ് ഇൻറ്റു വി ഡി എസ്, ദെൻ ഇഫ് ഇറ്റ് ഇസ് ലൈൻ റോയൽ വി ഡി എൽ, റൈറ്റ്? ഇനി we also know that what is rho v? Rho v is del dot d. Gauss law derive ചെയ്യുമ്പോൾ we'll get something like this. This is obtained from Gauss law for electrostatics. So now if you replace rho v, what will you get? This is our area of interest, volume integral, right? So WE will be equal to 1 by 2 volume integral del dot d into v. Only rho v is replaced with this Gauss law. So right now our equation is 1 by 2 volume integral del dot d into v dv. See, this is equation number 3. So once again I'm writing it. Now I have to use one identity. This is an identity, mathematical identity. To proceed further, just write down del dot v into a. V is a scalar quantity and a is a vector quantity. So it will be equal to a dot del v plus v into del dot a. This you have to memorize somehow, right? So which of this term is similar to this term over here? It is this term, right? So del dot a, similarly del dot d, and v is outside or v is outside. So keep this on the left side, ബാക്കിയുള്ളതെല്ലാം right side ലോട്ട് move ചെയ്യാം. So keep this over here and move this to this side. So del dot va minus a dot del v. This is our equation which we are going to use further. Now this del dot v into v we are going to replace by this particular equation. So it is 1 by 2 volume integral del dot ഇത് നമ്മുടെ കേസിൽ എനെ റീപ്ലേസ് ചെയ്ത് ഡി ആക്കാം. എ ഈസ് റീപ്ലേസ്ഡ് വിത്ത് ഡി, റൈറ്റ്? equivalent to d, I would say. So del dot va ന് പകരം vd minus a ക്ക് പകരം d dot del v, whole thing into dv. So insert, open the integral. So 1 by 2 volume integral del dot vd into dv minus 1 by 2 volume integral d dot del v into v you have to write. Now we are going to change this first term. This is your we. We are going to just change this first term. The second term remains the same. So first term is volume integral of del dot vd into dv, right? Now let's see Gauss divergence theorem. We have already know what does Gauss divergence theorem says. Psi is equal to q Then what is psi is surface integral of d dot ds. According to divergence theorem, this surface integral can be replaced by volume integral of del dot d d. We can replace it like this also. So this is the important equation. So this is വോളിയം ഇൻ്റഗ്രൽ നോ. സോ ഡെൽ ഡോട്ട് വി ഡി ആണ് അല്ലേ. അപ്പം വോളിയം ഇൻ്റഗ്രൽ ഡെൽ ഡോട്ട്. അപ്പം ഡിയുടെ സ്ഥാനത്ത് ഇപ്പം ഏത് ക്വാണ്ടിറ്റി എടുക്കുന്നത്? വി ഡി ആണ് കിടക്കുന്നത് അല്ലേ. അപ്പം അതിന് ഈ വോളിയം ഇൻ്റഗ്രൽ, ഈ ടേമിലെ വോളിയം ഇൻ്റഗ്രലിനെ കൺവേർട്ട് ചെയ്ത് സർഫസ് ഇൻ്റഗ്രൽ ആക്കുമ്പോൾ ഇറ്റ് ബിക്കംസ് ഡി ഡോട്ട് ഡി എസ്, റൈറ്റ്. സോ വാട്ട് യു ഹാവ് ടു റൈറ്റ്? ഡെൽ ഡോട്ട് വി ഡി ഇൻറ്റു ഡി വി വിൽ ബിക്കം വാട്ട്? I can write W is equal to 1 by 2 integral volume integral del dot VD. എങ്ങനെ മാറും? വോളിയം ഇൻ്റഗ്രൽ ബിക്കംസ് സർഫസ് ഇൻ്റഗ്രൽ, നോ. So del dot D becomes D dot ds, right? Instead of D here, VD. So we have VD into ds, right? See over here, the equation has changed to be like that. 1 by 2 surface integral VD dot ds. The rest, second term is same. Again, we know what is V is proportional to 1 by R and D is proportional to 1 by R square. That is, here we have considered that a big volume and we have considered this charges. So this is a small distance between the charge, right? So this is very small when compared to that bigger volume we are assuming, right? So this is very, very smaller value, right? So what happens? So that we can convert or we can take this term to equivalent to 0, right? So we have only the second term available. So we can neglect the first integral. Why? Because this point charge is extremely small. If you take the surface area value, whatever, that thing will be extremely smaller value. That's why we have to put it to 0. So the second term only exists, 1 minus 1 by 2 volume integral of del dot d dot del v into dv. Then we also derived one equation regarding electric potential, right? Potential gradient. We know what is potential gradient. So E equal to minus del V. We have derived in the first module. Also we know that D equal to epsilon E. രണ്ട് ഡാറ്റയും ഇവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. അതായത് ഡെൽ വിക്ക് പകരം നമുക്ക് we can put minus E, right? So minus E. So minus cancel ആയിപ്പോവും. So you can replace it the E over here. So volume integral D dot E dV ഇട്ടും equal to D can be written as epsilon into E, right? So when you substitute it, you will get epsilon 0 into E square into dV. This is a final equation that we are getting. Again, this is work done in positioning a charge from infinity to that point. Small charge, one small case. So total volume if you take, right? This is derived for the 3 charges and it's processed like that. Now we consider a big volume. This is a small work done, right? Small work done. So dw divided by dv you have to take. So you have to differentiate this entire term. So the integral will get cancels. So we'll get 1 by 2 epsilon 0 into e square. 1 by 2 epsilon 0 into e square. So can be also be written as epsilon e can be written as d. So this is 1 by 2 d dot e. Again, one more relation is there. This is d dot e, right? No, over here can be also written as d square by 2 epsilon. And this is more commonly used equation for work done or electrostatic energy density. Okay, thank you.